Hello everyone, welcome back to the video. Today we'll talk about air refrigeration system of type 4. I also came to know that a few people have dropped their weapons when it comes to RSE. I would like to continue that quote that उन पर है धिक्कार जो देखे ना सपना, सपनों का अधिकार असल अधिकार है अपना. Think about that and open your books for RSE. Let's continue with studying. So the topic is bootstrap evaporation air cooling system. So it is a combination of the type 2 and type 3. Type 2 was an evaporative air cooling system and type 3 was a bootstrap system. Now this is a bootstrap evaporative air cooling system. All systems remain same till this point. Even there are two heat exchangers like type 3. An extra point is just an evaporator. So what happens here is, till this point it is same as the earlier video. If you want to refer it, you could just go back into the third video and look for it. So when air comes here, it is cooled, that all is discussed. It goes to the second compressor, it goes again into the heat exchanger 2, then it goes to the evaporator. Now in the evaporator, the air is cooled more. Here the work of the evaporator is for high-ended flights where better cooling is required. We require more, no, for not for high-ended flights, for low speed flights. For low speed flights there is lesser compression due to ramming effect, therefore we need extra cooling. So whenever we need extra cooling, we need an evaporator, wherein in the heat exchangers the heat from the tubes is rejected to the rammed air passing to the shells. The same process repeats as discussed in third video. It passes through the heat exchanger 2, then it passes through the evaporator. Now the evaporator is filled with an evaporant. This evaporant accepts the heat from the tube air and it evaporates from these outlets. The CP value of the evaporant is very high. The HFG value, that is the latent heat of vaporization of evaporant, is very high and very good. That is, it has a better character to accept the heat and cool down the opposite fluid compared to the rammed air. So it is attached here. It accepts the heat from here, it evaporates, and this cool air is passed to the cooling turbine. Again, as discussed earlier, this cooling turbine is connected to the secondary shaft. Hence, this shaft doesn't require any auxiliary power. As this rotates due to the flow of this air, it rotates the shaft and the shaft powers the secondary compressor. Done. Now talking about the processes. 1 to 2 dash ramming effect, 2 dash to 3 dash in the main compressor. 3 dash to 4 is the cooling isobaric cooling effect, isobaric heat rejection to the rammed air. 4 to 5 dash is the isentropic compression in the secondary compressor. From 5 dash to 6 is the isobaric heat rejection in heat exchanger 2. From 6 to 7 dash is the expansion in this cooling turbine, and from 7 to 8 dash the air heats up to match the cabin temperature. As discussed earlier, the cabin temperature is somewhere around 22 degrees Celsius and the temperature here is can be somewhere very less than that 22 degrees Celsius. If the temperature difference is very more, then it can lead to condensation, and also it is very uncomfortable and over chilling for the passengers. So this very cold air is heated to a comfortable temperature of air, somewhere 22 degrees Celsius for example, and then that air is made to exit from the outlet to the cabin, like the air to the cabin. All the process remains same. Talking about the mass flow rate, again it goes from here. The only difference here is higher temperature cooling can be achieved because of the evaporators apparatus. Rest all the work and the COP remains same. Again, in the work we only consider the compressor work of this because this works on the bootstrap system only, so it doesn't require any auxiliary power. Hence in the work we only consider the work in the compressor 1, and the COP remains COP equals 210 Q by 60, that is 210 Q by 60 is kilojoule per second, and into work net in. This gets us kilowatt by kilowatt, both get cancelled, and it gets a dimensionless number. So we need to keep all the terms in kilowatt in COP for a better calculation. This was it for the fourth type. Thank you.